All right, so section 5.4, properties of midsegments. And we have defined what a midsegment is way back when we started to talk about triangles. All right, we know that a midsegment is a segment that connects the midpoints of two sides. All right, and we've applied them to triangles. Well, we're also going to apply them to a trapezoid. So let's take a look at some of these properties. The three midsegments conjecture. It states that the three midsegments of a triangle divide it into four congruent triangles. And you can see this play out in the diagram. We have one big triangle. We have the three midsegments there. And consequently, 1, 2, 3, 4, all of those triangles are congruent to one another. Now you might be saying, well, Mr. E, you told us don't assume something is true just because it looks like it's true. Well, we're going to come back to this in a couple minutes, and I'm going to show you how we could prove that this is true. We won't do the whole proof, but we'll talk about what that argument would look like. So the next conjecture is the triangle midsegment conjecture, and it states that the midsegment of a triangle is parallel to and is half the length of the third side. So in this diagram, we see the midsegment here. We now know that it is parallel to that third side, and it's half the length of the third side. So if I called the length of the midsegment x, then I know the length of this third side would have to be 2x. Now it's this conjecture that allows us to go back to the previous conjecture and actually show that these are indeed four congruent triangles. So let's just talk through this for a second. I think it's pretty interesting. So we know that these are three midsegments. So that's a midpoint, therefore those are congruent. That's a midpoint, therefore those are congruent. And that's a midpoint, therefore those are congruent. Right? We know all that. Now, this midsegment right here is going to be half the length of this base. Therefore, we know that this midsegment is congruent to the two bottom segments. This midsegment is going to be half the length of this base. Therefore, that midsegment is congruent to those two segments. And then finally, this midsegment is going to be half the length of this base. Therefore, it is congruent to those two segments. So we could easily prove that these four triangles are congruent by side, side, side. So next we apply midsegments to trapezoids, which I don't think we've done yet. So a midsegment still connects the midpoints of opposite sides. So this would be a midpoint, this would be a midpoint, right? That's the midsegment. And with the trapezoid midsegment conjecture states that the midsegment of a trapezoid is parallel to both bases. Okay, so parallel to both bases, and is equal in length to the average of the bases. Is equal in length to the average of the bases. So just hypothetically, if I called this base length x, and I called this base length y, and I called the length of the midsegment z, then we know that z would be equal to x plus y divided by 2, right? Or, of course, we could say z is equal to 1/2 times the sum of x plus y. Right? We're just taking the average of the lengths of those bases. And then one last thing. So this is taken right from our book. I just cut and pasted it. All right, and it's kind of interesting, so let's read what it says. What happens if one base of the trapezoid shrinks to a point? Then the trapezoid collapses into a triangle. The midsegment of the trapezoid becomes a midsegment of the triangle. And the trapezoid midsegment conjecture becomes the triangle midsegment conjecture. Do both of your midsegment conjectures work for the last figure? So let's look at the diagrams here. Right? They have this side, it looks like TF. And F is moving towards T until they become the same point, and the trapezoid becomes a triangle, right? And the midsegment of the trapezoid, MD, shrinks as well until it becomes the midsegment of the triangle, right? We see this happening. Now the question is, do both conjectures, the trapezoid midsegment conjecture and the triangle midsegment conjecture, do they both apply to this last figure? And the answer is yes. Because, let's go back for a second to this. Right? Over here on the left, we said that the length Z, the length of our midsegment, would be the average of the two bases. Well, what if one of the bases had a length of 0? Right? Then this equation, Z equals X plus Y over 2, will become 0 plus Y over 2, or just Y over 2, which would be half of the bottom base, right? And at that point, that is the triangle midsegment conjecture, right? So if you have that understanding, the trapezoid midsegment conjecture and the triangle midsegment conjecture are essentially the same thing, right? It's just that with a triangle, one of the lengths of the bases is 0.